Isaac Newton came up with 3 principal laws of motion that we can see all around us today, the first of which is his law of inertia. Now, before we look at this law a little more closely, I'd better describe what inertia is first. So, inertia is an object's resistance to change its motion. The more mass an object has, the more resistant it is to change, thus, the more inertia it has. We can summarize this by saying that there is a direct proportionality between mass and inertia. And this makes sense, because the more massive an object is, and on Earth we basically think of it as the heavier it is, the harder it is to move. So what Newton's first law is basically saying is that when an object is not moving, it tends to stay that way. And when an object is moving, it also tends to stay that way. But there's a catch. That's only when there are no unbalanced forces acting on that object. This is easy to see when there's a rock just sitting there. It doesn't start spontaneously moving on its own, so that means that there are no unbalanced forces acting upon it. But when someone starts pushing on that rock, it creates an unbalanced force in that direction, so the rock starts moving. And when the person leaves, it goes back to staying stationary because that unbalanced force left the system. And what if an object is already moving at a constant speed? Well, that also means that there are no unbalanced forces acting upon an object, so that object is going to move at that constant speed forever. Take a block of ice and a sheet of ice. Let's say that the block of ice has already been moving at the time we started observing it. Since friction is negligible in this case, there are no forces working to stop the ice block's motion, so it would just keep moving and moving forever. Newton's second law is the law of proportions. Newton noticed that as the amount of force increased on an object, the acceleration increased as well, in the same direction. So let's go back to the person pushing the rock example. If the person exerts a small force on the rock will only speed up a little bit. But if the person exerts a big force on the rock will speed up a lot in that same amount of time. And it's speeding up in the same direction that the person exerts that force in. But Newton also noticed that the more massive the object, the smaller its magnitude of acceleration. That is, mass and acceleration have an inverse proportionality. So instead of changing the force that the person exerts, let's change the rock itself. The smaller the rock, the faster it accelerates, but the more massive the rock is, the slower it accelerates. We can combine these two proportionalities into one equation, F equals ma, or force equals mass times acceleration. It's important to note that force in this equation is the net force, or the combination of all the forces, and not just any random force. Newton's third law can be seen as a law of interacting pairs. Basically, when one object exerts a force on a second object, that second object exerts a force of the same magnitude but opposite direction on the first object. This is what allows rockets to go into outer space. The engine of the rocket shoots fuel out of one end downwards, and the Earth pushes back upwards with an equal magnitude, causing the rocket to be propelled up and beyond. So I hope this video cleared up any questions you had about Newton's 3 laws, and thanks for watching!